problem called as a top view of a binary tree. Here we have given a binary tree with n nodes, and the top view of a binary tree is a set of nodes which are visible when we see a tree from the top. Find the top view of the given binary tree from left to right. So when we see this tree from the top, we can notice that will be only visible with the nodes 10, 4, 2, 1, 3, 6. So we have to print the top of a binary tree in the format called as a left to right. So we have to return what actually we have to return. We have to return the vector giving the top view of a binary tree from left to right. Here in this example, we can see we have a tree saying 10, 4, 2, 1, 3, 6 as a top view of a binary tree from left to right. So I'll be solving this problem in a two way. So first way we will be using the map and the column technique that we have been used in the previous problem of this drivers SDE A to Z sheet. So this will be the similar problem, and only the change we have find here is that we'll not going to change the map will not going to insert the value in the map in the form of set. We'll be just mapping with the column. If that value is previously present in the map, will not going to change that value. So let's say before going ahead, we need a queue and we'll need a map to store the column with the particular mapping of its level. Let's say this is the zeroth will be starting, so this is the root of the tree. When we move to the left, will make the column as column minus 1, and when we move to right, we make the column as column plus 1, saying that this is the particular column of that particular let's say two-dimensional vector. But we're not going to insert all the nodes. Will be just inserting the first node that will be visible. Of course we'll have to insert the only one node, because we these nodes won't be visible from the top, so we are not going to insert. And when we move from top to bottom, we'll be only coming up with the nodes 2, 4, and 10, and these nodes will not be visible in our binary tree from the top view. So let's begin with the solution. We'll first need a queue with pair having tree node as one pair component and integer as the other pair component, and we'll make the queue as queue. So we'll push the initial root of the tree, saying this is the root and this is the column. So this is our first step. Also we'll need a map. So map is going to be as integer and map. So this is the simple step. So let's move on to the next step, which is iterating through this binary tree one by one. Let's say if has a left node, we'll move to the left node by taking it out, like by taking one column as a column minus one, and when we move to the right, we'll make it as column plus one. So before going, uh, we don't have to initialize map. We'll be just directly putting it there. So let's say we have started iterating. We will be iterating until we will be empty with our queue. Okay, so this will be our queue, and we'll be iterating over this. And finally, when we complete iterating, this queue will be ending up with a map in a sorted fashion from left to right, uh, and uh, it will be storing the values of that particular map, values of that particular node in a particular map, right, in a map value. So let's say we have ready with our map, and let's say we have auto it map. Now we have to return the answer. We have to return the vector. So we'll make a vector called integer ns. Now we have to push into our vector. What we have to push? We have to push the mapping value. Let's say map of uh, it dot second. Uh, yeah. map of id of second value we have to print. I'm not sure about the syntax, we'll see it later. This is the our answer and we'll be returning this answer. So now move on to the main logic of our code. So when we have the queue is not empty, what we have pushed already, we have pushed the root node of the tree. So we'll be taking it into the temporary root temporary variable called as a temp, which is the queue dot front dot first, and we'll be making one called as a column, and it is in the second, I think. Yes, it is in the second part of our queues pair, and it is in the second. So now we will check whether this particular column is there in the map. How we will check? We will use map.find method. That is, if it's not, if it's equal to map dot end, means it's not there, and we will simply insert it into our map. Let's say column, and what we have to insert? We have to insert the value of that, how we have represented the value using the data. So data is inserted. Else what we will be do, what we'll do, we will go to the left and right of the tree. Else we are not going to go in else. Anyway we have to do it every time. So let's say if our temp node have the left, and if our temp node have the right, so we'll be using this logic. If it's have a left, we'll be simply pushing it into the queue with the temp of left, making column as -1 as I have said previously. And if it has the right, we will be making it as a temp dot, we'll pushing it as temp dot right, making column as column plus 1, and we'll pop it at the end. So this is going to give us the map that stores the uh, temp data column wise in a sorted fashion. Let's try running it. I am sure that there will be a syntax error. So let's I'll logging it with my account first. I'll just simply copy it. Logging in. You can see the code is gone. So thank God I have copied it. So we can see my account is back, and now I can run this code. Let's see what will be the error or anything we will see. Unable to deduce auto, unable to deduce auto, map unexpected primary expression. So we can't map to map. So we'll make it as MP map map. And wherever we find map, wherever we find what map, wherever only where the map is used. Well, let's say here and here. Okay, this looks good. Let's see what is the error now. Okay, map has not declared in the scope. I think the library is not installed here. Let's include the library like include /std c++ running. Okay, sorry. Now you can see all the test cases are passed, right? Let me try again running this. Yeah, all the test cases are passed. Now I will try to submit this code. Yeah, we can see the all the test cases are passed. So this is the simplest way to do this using the map. I have the another way which I'll be showing you. This is the another way which I have firstly thought that we can solve this using the two queues. So the first queue is to iterate through the tree, and second queue is going to store the uh, mapping of our tree in the left right fashion. So this and this one is in the right. So let's say we'll be moving in the left side of the tree. It will be making the left plus one, and will be left minus one, and when will be sorry, left plus one only, and will be going to right, it will make the right plus one. Here in the code we can see I have make it as left plus one and right minus one. Of course, when we move to the left, the right should be minus one. And when after doing this, I have iterated through the another queue, and I have checked whether that L value is greater than curl left. Basically, this curl left is the current position where we have stand out. Let's say we are at here, and we are checking for this variable. So what is the current left position? Here we can see left plus one means this is at the 1th position, and when we move to the again left, so it will be 1 plus 1 2. So 2 is obviously greater than 1, so we will be inserting this 4 into our left vector, and again we'll be doing the same for the right vector, and then we are merging those both two vectors and will be returning as uh, left vector as the answer. Here you can see I am combining both. So this is it, guys.